I'm gonna go ahead and tell you a little bit about titanium. It's the 22nd element on the periodic table. It's classified as a rare metal. It has the highest strength to density ratio of any metallic element. It has a natural resistance to rust and oxidation, which is very cool for a lot of the applications we use. These being on cars, they're exposed to a number of different elements. This material, the only downside to it really is it's not able to be casted, as well as shavings and dust. It is very flammable. There's a wide range of things that they use this stuff on. It's used in aerospace, medical field. It's structurally very strong, as well as they use it on satellites, the race car industry, race cars. Also, it has a low thermal expansion, actually 50% less than any other steels, and it has a very high melting point of about 3,000 degrees, which is about 1,600 degrees Celsius. How you doing? Welcome to Weld.com. My name is Jeff Ray. I'm gonna be a new guest host here. I'm gonna take you through some titanium welding processes. We're gonna be building this bike here, a series of videos, so we'll get at it. I'm a welder fabricator. I work for Hefner Performance, as well as I build turbo systems for Ballistic Cycles. I've been welding and fabricating for over 10 years now. Started out in the process, got into the exotic cars and more of the exotic materials, and we're gonna take you through some processes here through the titanium on this series build. I'm gonna take you through the process of building this here twin turbo system. It's gonna be a custom full titanium turbo system for this Harley V-twin engine. Not only just individual components, but custom components for it, as well as the weld process. Not only is this material an exotic material that is very aesthetically pleasing to the eye, but the weight savings of it. We're adding turbos here. They add a lot of weight, so we're gonna minimize the weight elsewhere in this material. It's gonna help the performance of this bike, and it is gonna do some cool things. Here's some of the components we're gonna be using on this here twin turbo system. We got twin aero chargers going on the bike. We have the Tile Q series blow off valve that's gonna be utilized as well. We have the ProFlow Wiggin style clamps that are gonna be utilized on the charge pipe system to ensure no leaks, as well as all Tycon pie-cutted fittings. As you see, there's a lot of welding to be done here. First thing we're gonna be doing here is building the header flange piece. So I'm gonna need to cut these reducers back a little bit, as well as weld a ring to the end of this pipe so the snap ring can be held on there and the flange doesn't slide off. I have here an 1.5" by 2" reducer. I need a 1 3/4" by 2" reducer. So I'm gonna lay it out and make that first cut. This backing plate is carbon steel. I don't want to transfer that to the titanium, as well as it'll scratch it. So what I like to do is I'll take tape, put 2 or 3 layers on here so it doesn't scratch the material at all and doesn't cross-contaminate. We started out with a 1 3/4" piece of tubing, cut it 1 inch long, as well as a piece of 2" tubing, cut 7/16 of an inch long. 2" is a lot bigger than the 1 3/4". What I'm gonna do here is weld these two faces together. So I'm gonna have to cut a relief cut in the 2" piece and then take a section out so it'll lay seamlessly together, and then we'll make this weld here. We also took a 1.5" by 2" transitional concentric reducer and cut it in half to have a 1 3/4" by 2" transitional reducer. Now that we got it cut, we're gonna start by tacking it around, working the piece around tight, and then we'll cut the excess off that we need there. We got the Everlast Power TIG 200 DV with the built-in water cooler here. We're gonna weld the titanium on DC. Turn the amperage down to about 28 amps. We want a long post flow. We gotta shield this really good. So as well, we got the Furic BBW cup on here as well with the solution torch. We did some titanium welding here with the TIG on this Everlast. Did some autogenous welding where we had fused together this ring that's gonna allow the snap ring to be held on there. This is gonna be the first component. We're down here in Bradenton, Florida in my garage where I'm building the second turbo system for this here Harley-Davidson for Ballistic Cycles. First thing we're going to do today is go through some of these fittings here and get them taped together. So when I'm doing a custom project like this, I'll over order on the different degrees and center lines of the fittings here. So they'll come with tight radius fittings and a loose radius fitting depending on the flow of the bike, how we want the pipe to contour around the frame or around the engine. So I'm going to go through and we're going to tape a couple of them together. I'm going to show you how I do that. I like starting off with a square fit first. So we're going to make square 90s out of these pieces. And I'm going to show you how I figure out that they're square. From there, we'll fit some up on the bike and start with the first component there. Titanium likes to retain oils. It doesn't clean very easily. I got a can of acetone here on the side to clean it. But so how I indicate, like I said, fitting these up and getting a square 90 fit, how these fittings are cut, they use the seam weld. So when they cut it, and then they'll have to rotate the pipe 180 degrees to get that square cut. So that is a good indicator mark of how these things are going to fit square together. So by looking through the inside, I will align the seam welds. And I'll have tape laid out here, and then I'll start by laying a piece of tape and we'll build the whole 90. We got the first one taped together here. As you can see, this is a very tight radius 90. The 1D being 1 times the diameter of the pipe. This being a 2-inch OD tube, it's going to be a 2-inch centerline radius 90. That's going to be our tight 90. Then we got here the 2D, which is going to be 2 times the diameter of the pipe. This being 2-inch OD tube, we're going to end up with a 4-inch centerline radius. That's going to be our loose radius 90. The purpose of having 2 different centerline radius 90s here is it gives me the fitting ability to fit this pipe around the bike how I want. So I'm going to have places where I'm going to be really tight on space, and that's where the tight radius 90 is really going to help me. And then for the flow, aesthetically, the loose diameter one's going to look very good, and it's going to allow me a bigger arch in the flow of the pipe. We got that bolted in here now. We want the pipe to come out. It's going to loop back around and through here. This pipe's going to feed all the way around to the right side of the bike here to this first turbo. That front cylinder is going to wrap around that front down tube and go to the turbo on the left side of the bike. So we got to sneak this pipe back through here. I want to come out a little more. We're going to utilize the tight radius fittings on this piece here. As you can see, it's very tight. Now that we got our first piece fit up here, we're going to go ahead and tack it up. We got the Everlast 210 EXT that we're going to be utilizing. I've got my Furic BBW cup and my 332 E3 tungsten that we're going to be using. Not going to be needing any filler metal on this unless I got a spot that needs it, but these pieces being cut so precise, I got a really good fit up, so I don't think I'll be needing any of that. I will have a piece here just in case. I like to set my post flow time really high in between tacks. I don't have the gas shutting off or the solenoid on there triggering back and forth. So it's just going to be flowing constantly. Once I get the piece tacked up, I'll take a piece of Scotch-Brite and scuff the whole thing out. I like a brushed finish on this stuff. It looks really good when it's welded out. We got our argon set at 35 CFH. We got the first piece tacked up here. Now we're going to check the fit here on the bike. Make sure it's what we want. All right, that's it for episode 1 here with the custom titanium twin turbo system for Ballistic Cycles. I got a lot of welding to do. I'll see you guys back up at the shop. And remember to like, subscribe, and make every weld better than your last.